This is a question on kinetics. There are 3 sections, A, B and C, 7 marks in total. So pause, have a go at each section and then review your answers. Here's part A, part B, and finally part C. And now taking a look at the answers. So we want the Maxwell-Boltzmann curve, in this case for a lower temperature. When we're looking for a lower temperature, first of all, this is the peak that you are aiming for. And we're going to show what the 2 marks are worth. So I've colour-coded the ticks. 1 is for showing that the peak has moved up and to the left. That's because there are more particles with less energy. So there'll be more that actually have the more probable energy. So the peak gets higher. But the average energy is lower because the total amount of energy is lower. The second mark that you get is for only crossing the other Maxwell-Boltzmann curve once. So if you were to extend your line to the right-hand side and touch the other Maxwell-Boltzmann curve, or indeed touch the x-axis, you would not get that second mark. Moving on to part 2, the effect of lowering temperature on the rate of reaction. Now it's only 2 marks, you don't need to write down a huge amount at all. Firstly, it would decrease the rate lowering the temperature. Fairly straightforward mark to pick up. Now, when you're explaining why, be very, very careful. We're not just saying there are less successful collisions. We need to talk in terms of the frequency of successful collisions. And that's what gets you to mark number 2. And then we move on to part C. We have got a Maxwell-Boltzmann curve with a second sample curve added on. We want to know what change has been made, and we want to know what effect it would have on the rate of reaction. Now, this in part hinges on you remembering that the area under the curve is equal to the total number of molecules. So in sample 2, the area is smaller, so there are less molecules of the sample. You could also talk about it being a lower pressure. Now, if that's the case, there will be a lower rate of reaction for the second mark. And then finally, we can talk about the fact that the particles are further apart. That means there will be less collisions, therefore there will be less successful collisions, therefore the rate of reaction will be lower. But we've got all of the marks there.